So today we are going to solve this paper. So the first question is if f is to r tends to r is defined by f of x that equals to 3x minus 5, then prove that f of x is an onto function. So let us take let y be an any real number. So we need to find the x such that the onto function formula is f of x equals to y. They are already given that f of x equals to 3x minus 5. So from this, let us take this as y equals to 3x minus 5. So for solving x, we need to get that y plus 5 equals to 3x. That means x equals to y plus 5 by 3. So here, since y is a real number, we can see that x is also a real number. So for every real number, there exists a real number. That means for every real number of y, there exists a real number of x, such that f of x equals to 5. So f of x is an onto function, hence prove. Next, second question is resolve x by x minus 1 into x minus 3 into partial fractions. So the partial fractions formula is x by x minus 1 into x minus 3. This can be expanded into a by x minus 1 plus b by x minus 3. So multiplying both sides of the equation with x minus 1 and x minus 3 and then substituting this value x minus 1 equals to 0. That means x equals to 1. So that means x equals to a into x minus 3 plus b into x minus 1. So here substituting the value x as 1. So the value we get of a is a equals to minus 1 by 2. Next, by again here by taking this x minus 3, that means x minus 3 equals to 0, that tends to x equals to 3. Now substitute x equals to 3 in this equation. That tends to x equals to a into x minus 3 plus b into x minus 1. Then by substituting x equals to 3, we get the value b equals to 3 by 2. So a equals to minus 1 by 2 and b equals to 3 by 2. Substitute the values in that expression. Third question, if a equals to 2, 3, 1, 2 and b equals to 0, 4, minus 1, 2, then find ab and ba and also show that ab is not equals to ba. So the multiplication of two matrices 2, 3, 1, 2, 0, 4, minus 1, 2. So how we multiply? First row, first column. So we can multiply in many ways. So like this 2 into 0 plus 1 into 4 or any else. So from this section we can see that 2 into 0 plus, that means they are multiplying like this. First row, first column. So 2 into 0 plus 3 into minus 1. And next one 2 into 4 plus 3 into 2. First row, second column, this place. And here second row, first column, 1 into 0 plus 2 into minus 1. Next second row, second column, 1 into 4 plus 2 into 2. So here are the values minus 3, minus 2 and 14 and 8. And again now multiplying b into a. So first one 0 into 2, first row, first column, 0 into 2 plus 4 into 1. And here first row, second column, 0 into 3 plus 4 into 2. Again second row, first column, minus 1 into 2 plus 2 into 1. And here this place getting second row, second column multiply, minus 1 into 3 plus 2 into 2. So the value is 4801. And here we can see that AB is not equals to BA. Hence proved. Now let us go on to the fourth question. Prove that cos 12 degrees plus sin 12 by cos 12 minus sin 12 is equal to tan 57. So by taking LHS, cos 12 plus sin 12 by cos 12 minus sin 12, that equals to, so by multiplying cos 12 by cos 12 plus sin 12 by cos 12 by cos 12 by cos 12 minus sin 12 by cos 12. So we know that cos by cos 1, sin by cos, that equals to sin theta by cos theta equals to tan theta. So tan 12 by tan 12. So you know the formula of tan a plus b, that tan a plus b equals to tan a plus tan b by 1 minus tan a tan b. Here we know the formula that tan 45 equals to 1. So here, so from this 1 plus tan 12 by 1 minus tan 12, that means tan 45 plus tan 12 by 1 minus 1 into tan 12, that means tan 45 minus tan 45 into tan 12. So here tan a plus tan b by 1 minus tan a tan b. It is in the form. So tan a plus b, that equals to tan 45 plus 12, that equals to tan 57. LHS equals to RHS. Next one, fifth one. Prove that 1 minus cos 2 theta by sin 2 theta equals to tan theta. So by taking this LHS, we know the formula of cos 2 theta, that equals to cos square theta minus sin square theta. And sin 2 theta formula is 2 sin theta cos theta. So substituting these two formulas in this LHS, we get the value of 1 minus cos square theta plus sin square theta by 2 cos theta into sin theta. You know that sin square theta plus cos square theta equals to 1. So that means 1 minus cos square theta equals to sin square theta. So sin square theta plus sin square theta by 2 sin theta cos theta, that equals to 2 sin square theta by 2 sin theta cos theta, that equals to, by cancellation, sin theta by cos theta, that equals to tan theta. So LHS equals to RHS. Sixth one. Find the additive and multiplicative inverse of the complex numbers 4 minus 5i. Additive inverse, that means changing the sign of both the real and imaginary parts. That means minus 4 plus 5, 8. So the additive inverse of 4 minus 5i is minus 4 plus 5i. And to find the multiplicative inverse of 4 minus 5i, so we need to multiply 4 minus 5i with a plus bi. That means 4 minus 5i into a plus bi equals to 1. That means 4a plus 5b equals to 1. So from this, that means we need to find the additive inverse. So minus 5a plus 4b, that equals to 0. So from this, that means by solving these two equations, we get the value of a comma b as 4 by 41 and b equals to 5 by 41. So substituting this a and b, therefore the multiplicative inverse of 4 minus 5i is 4 minus 5i whole inverse, that equals to 4 by 41, the value of a plus bi, a plus bi, this form. So 4 by 41 plus 5 by 41 I. Next question. Find the acute angle between the lines 2x plus y plus 4, that equals to 0, and y minus 3x equals to 7. So let us take this equation as 1 and this equation as 2. That means from this equation, we know the formulas. So by slope m1 equals to minus a by b. We know the formulas there. So from this two equations, minus a by b. So that equals to minus 2 by 1, that equals to minus 2. And this one minus of minus 3 by 1, that equals to 3. m1 equals to minus 2, m2 equals to 3. So to find the formula that the angle of the acute angle, we know the formula that tan theta equals to m1 minus m2 by 1 plus m1 m2. So by substituting m1 minus 2 and m2 3 in this equation, in this formula, then we get the value that 1. Tan theta equals to tan, that means tan theta equals to 1. That means tan 45 equals to 1. So theta equals to 45 degrees or pi by 4. Next one. Evaluate limit of x tends to 0, tan 7x by x. We know the formula that limit x tends to theta, tan mx by mx, that equals to 1. So here tan 7x into 7 by 7x, that equals to 1 into 7. So that equals to 7. So next one. Find the derivative of 2 root x plus 3 cosecant x plus 4 tan x with respect to x. So let us take this as f of x, that equals to 2 root x plus 3 cosecant x plus 4 tan x. So by using the chain rule, f dash of x equals to 2 into 1 by 2 x power 1 by 2. Root x equals to x power 1 by 2. So by differentiating this, half into x power 1 by 2 minus 1, f dash of x equals to. So that means half into x power 1 by 2 minus 1, that equals to minus 1 by 2. So 2 into 1 by 2 into x power minus 1 by 2 plus 3 cosecant x. So the derivation is minus 3 minus cosecant x into dx plus tan x secant square x plus 4 secant square x. And f dash x is equals to x power minus 1 by 2 minus 3 cosecant square x cot x plus 4 secant square x. The derivative is this one. Next one. Find dy by dx if y equals to t square and x equals to 2t. Dy by dx, that means in terms of t. So by using the chain rule, dy by dt, that equals to d by dt of t square. That equals to d by dt of t square equals to You know the formula that d by dx of x power n equals to n into x power of n minus 1. So d by dt of t square equals to 2 into t power of 2 minus 1, that equals to 2t. And dx by dt, that equals to d by dt of 2t, that equals to 2. So we know the values of dy by dt and dx by dt. So by using the formula for the derivative of by with respect to x, dy by dx equals to dy by dt by dx by dt, that equals to 2t by 2, that equals to t. So the value of dy by dx is equals to t. Next, part B. Find the inverse of the matrix 3, minus 3, 4, 2, minus 3, 4, 0, minus 1, 1. So, first by taking adjacent of A1, 1. That means first row, first column. That means closing this side. First row and first column. Minus 3, 4, minus 1, 1. So, this is one, the adjacent. Minus 3, 4, minus 1, 1. So, to solve this matrix, minus 3 into 1, minus of minus 1 into 4, that equals to minus 3 plus 4, that equals to 1. And now adjacent of A12, that means first row, second column. So first row, second column, closing this, 2, 4, 0, 1. 2, 4, 0, 1. So 2 into 1 minus 0 into 4. So that equals to 2. Adjacent of A13, that means first row, third column. So 2, 0, minus 3, 1. So the adjacent of 1, 3, that means first row, third column. So 2 minus 3, 0, minus 1. 2 into minus 1 plus 0 into minus 3, that equals to minus 2. Adjacent of A21. So that means second row, first column. That means second row, first column means minus 3, 4, minus 1, 1. That equals to minus 1. Next, adjacent of 31, that equals to minus 3, 4, minus 3, 4. That equals to minus 3 into 4 plus minus 3 into 4. That equals to 0. Adjacent of A32, that equals to 3, 4, 2, 4. So 3 into 4 minus 2 into 4, that equals to minus 7. Adjacent of A22, that equals to 3, 4, 0, 1. That means 3 into 1 minus 0 into 4, that equals to 3. Next, adjacent of 23, 3 minus 3, 0, minus 1. 3 into minus 1 minus 0 into minus 3, that equals to 3. Adjacent of A33, that equals to 3 minus 3, 2 minus 3. That means 3 into minus 3 minus 3 into 2, that equals to 3. So mod A equals to 3 into minus 3 plus 4 minus 2 into minus of 3 plus 4 plus 0. So that equals to 1. That means you know the formula that A dash equals to adjacent A by mod A. Already we know the value that. So from this, adjacent A value is adjacent A by mod A. Adjacent A values are here. Already we found this. So 1, minus 2, minus 2, minus 1, 3, 3, 0, minus 4, 3. That means adjacent A values A11, 1, minus 2, minus 2, minus 1, 0, minus 4, 3, 3, 3. So substituting this here into multiplying by dividing 1. So this is the matrix. Next one, 11th one. Solve the following section system of linear equations using Cramer's rule. X plus 2y plus dz equals to 6, 3x minus 2y plus 4z equals to 5, and x minus y minus z equals to minus 1. So taking this, here x values and here y coefficients and here z coefficients, and here this side is let us take these as series coefficients. So 1, 2, 3, 1, 2, 3, and here 3 minus 2, 4, and here 1 minus 1 minus 1, 6, 5 minus 1. So taking this as matrix, let us take this as D, this matrix. So 1, 2, 3, 3 minus 2, 4, 1 minus 1 minus 1. So by solving this matrix, how to solve this? 1 into first row, first column, first column, first row close. So minus 2, 4, minus 1, 1. Minus 2 into first row, second column close. 3, 4, 1, minus 1. Here. Plus 3 into first row, third column close. 3 minus 2, 1 minus 1. So solving this, 1 into minus 2 into minus 1 minus of minus 1 into 4. Minus 2 into 3 into minus 1 minus 1 into 4. Plus 3 into 3 into minus 1 minus 1 into minus 2. So solving this value, we get the value of 17. Next, dx. Let us take this as dx. That means 6, 5 minus 1 and 2 minus 2 minus 1, 3, 4 minus 1. That means substituting 131 values, 6, 5, minus 1, replacing. So now let us find this value dx. So this is the formula of Cramer's rule. That means substituting this 6, 5, minus 1 in the place of x coefficients, first column. So the value is, so again same model, substituting 6 into minus 2, 4, minus 1, minus 1, minus 2 into this one close. So 5, 4, minus 1, minus 1, plus 3 into 5, minus 2, minus 1, minus 1. So solving this one value, 6 into minus 2 into minus 1, minus of minus 1 into 4, minus 2 into, so solving like this we get the value that 17. So D equals to dx. And now substituting that 6, 5, minus 1 in the place of y coefficients. So again solving this dy value, we get the value that 9. And now dz, that means substituting 6, 5, minus 1 in the place of z coefficients. And now we get the dz value as 17. So we know the formula that x equals to dx by d. Already we know the value that dx equals to 17 and d value is 17, that equals to 1. And y equals to dy by d, that equals to 9 by 17. And z equals to dz by d, that equals to 17 by 17, that equals to 1. So the xyz values are 1, 9 by 17 and 1. Now 12th one. Prove that sin square a plus sin square 60 plus a plus sin square 60 minus a equals to 3 by 2. So now taking the LHS value, sin square a plus sin square 60 plus a plus sin square 60 minus a. You know the formula that sin square 60 plus a, that equals to, it can be written as half into 1 minus cos square of 60 plus a. Now the formula that sin square theta equals to half into 1 minus cos 2 theta. So half into 1 minus cos 2 into 60 plus a plus half into 1 minus cos 2 into 60 minus a. So 2 into 60 120, 2 into a 2a, 2 into 60 120, minus of 2 into a minus 2a. So we got the value of like this expression. So now solving this one, sin square a plus 1 minus half into 2 into cos a plus cos b, formula is cos a plus b by 2, plus cos a plus cos b, formula cos a plus b plus cos a minus b, formula is 2 cos a plus b by 2 into cos a minus b by 2. So substituting this formula in this equation, we get the value as sin square a plus 1 minus cos 120 into cos square a. So that means sin square a plus 1 by 2. So that means 1 plus 1 by 2 into 1 minus 2 sin square a. So 1 plus 1 by 2 into 1 by 2 minus 1 by 2 into 2 sin square a. That means 2 cancel. So minus sin square a plus sin square a minus sin square a cancel. That means 1 plus 1 by 2, that equals to 3 by 2 is equals to LHS. LHS equals to RHS, hence proved. Next 12b. Prove that tan inverse 3 by 4 plus tan inverse 3 by 5 minus tan inverse 8 by 19 equals to pi by 4. That means taking this LHS, we know the formula that tan inverse of a plus tan inverse of b, that equals to tan inverse of a plus b by 1 minus ab. So taking this as a and taking this as b, tan inverse of a plus b by 1 minus ab. So this is the value. 15 plus 12 by 20 by 20 minus 9 by 20. 20 cancel. 15 plus 12 27. 20 minus 9 11. So tan inverse of 27 by 11 minus tan inverse of 8 by 11. So we know, as we know the formula, again by substituting the formula, tan inverse a minus tan inverse b, that equals to tan inverse a minus b by 1 plus ab. So substituting 27 by 11 minus 8 by 19 by 1 plus 27 by 11 into 8 by 19, that equals to 513 minus 88 by 209 by 209 plus 216 by 209. 209 cancel. Tan inverse of 425 by 425. Tan inverse of 1. That means tan inverse of 1. Tan pi by 4 equals to 1. That means tan inverse of 1 equals to pi by 4. Next, 13th one. Solve the equation sin 6 theta cos 2 theta minus sin 5 theta into cos theta equals to 0. So now we know by taking this LHS value, we know the formula that sin A plus B equals to sin A cos B plus cos A sin B. That means sin 6x plus 2x minus sin 5x plus x equals to 0. It is in the form sin A cos B minus cos A sin B. So that means A equals to 6 theta, B equals to 2 theta. This one. So sin 6x plus 2x minus sin 5x plus x equals to 0. Sin 8x minus sin 6x equals to 0. That means sin A minus sin B. We know the formula of sin A minus sin B, that 2 cos A plus B by 2 into sin A minus B by 2. So substituting this one here, we get the value of 2 cos 7x into sin x equals to 0. So here this equation is satisfies either cos 7x equals to 0 or sin x equals to 0. So from this equation, cos 7x equals to 0, sin x equals to 0. So that means when 7x equals to 2n plus 1 into pi by 2, that means where n is an integer, so cos 7x equals to 0. And when x equals to 2n plus 1 into pi by 7 into 2, that means 14. So x equals to 2n plus 1 into pi by 14, where n is an integer, sin x equals to 0. So that means sin 6 theta into cos 2 theta minus sin 5 theta into cos theta equals to 0. Hence proved. So now moving on to the 13th question. B is, in a triangle ABC, show that cot A by 2 plus cot B by 2 plus cot C by 2 by cot A plus cot B plus cot C equals to A plus B plus C whole square by A square plus B square plus C square. So from this, you know the formula that cot A by 2 equals to S into S minus A by delta. That means as they have given that in a triangle ABC. So the formula is S into S minus B by delta of cot B by 2. Cot C by 2 equals to S into S minus C by delta. So now cot A equals to b square plus c square minus a square by 4 delta. So now substituting this value, s into s minus a plus s into s minus b plus s into s minus c by delta by whole by a square plus b square plus c square by 4 delta. That means delta cancel, and this 4 goes in this place of numerator. So 4s into 4 into, that means 4 into s minus a plus s into s minus b plus s into s minus c. By solving this, 4s into 3s minus a minus b minus c by a square plus b square plus c square. So from this, taking out 4s into a plus b plus c by 2 by a square plus b square plus c square. That means a plus b plus c by 2 into a plus b plus c by 2 into 4 by a square plus b square plus c square. 2 same cancel. So that means a plus b plus c whole square by a square plus b square plus c square. Hence proved. Next, 14th question. Find the equation of the circle passing through the points 1, 1, 2, minus 1 and 3, 2. So let us let the circle equation be x square. We know the formula that circle equation that x square plus y square plus 2jx plus 2fy plus c equals to 0. So by considering this as circle equation, then the circle passes through 3 points. So they should satisfy the circle equation. So first point is 1, 1. So for point 1, 1, 1, substituting this 1, 1 in the place of x, y, 1 plus 2g plus 2f plus c equals to 0. So 2g plus 2f plus c equals to 2. This is equation 1. And now substituting the points 2, minus 1 in the place of x, y, we get the equation of 4g minus 2f plus c equals to minus 5. And point 3, which is 3, 2. 3, 2 in place of xy, then we get this equation. So we are, by substituting the given 3 points in the circle equation, we get 3 equations. So now solving equation 1 and solving equation 2, we get the equation 6g plus 2c equals to minus 7. This is taken as equation 4. Now multiplying the equation 2 with 2 and solving it with equation 3. So we get the formula equation, another equation, that is taken as equation 5. Now multiplying fourth fourth equation with 3 and fifth equation with 2, now we get this equation, these two equations. So multiplying by doing this, so minus 60 cancel. So 18 minus 28 minus 10g equals to minus 21 minus of minus 46, so that equals to 25. So here we got the value of g value. So substituting this g value in this equation, fifth equation, we get the value of c here. That equals to c equals to 4. So we got the values of c and g. Now substituting these values in equation 1, which is 2g plus 2f plus c equals to 2. 2g plus 2f plus c equals to 2. We get the value of f. Here we got the value of c, and here we got the value of f, and here we got the value of g. So now substituting g, c, f in the equation x square plus y square plus 2gx plus 2fy plus c equals to 0. Substituting this equation, we get this equation x square plus y square minus 5x minus y plus 4 equals to 0. Next, 14b. Find the equation of the rectangular hyperbola whose focus is the point minus 1 comma minus 3 and directrix is the line 2x plus y plus 1 equals to 0. So the required hyperbola is x minus of minus 1 whole square plus y minus of 3 whole square. So x plus 1 whole square plus y minus 3 whole square, that equals to 2x plus y plus 1 whole square. So solving this solving this value, x square a plus b whole square, a square plus b square plus 2ab. So x square plus 1 plus 2x plus a minus b whole square, a square minus b square, a square plus b square minus 2ab. So this value, and here a plus b plus c value, a square plus b square plus 3 square plus 2ab plus 2bc plus 2ac. So by substituting this equation, by solving this equation and cancelling the equal values here, we get this equation. So this is the equation of rectangular hyperbola. 3x square plus 4xy plus 6x plus 2y minus 10 equals to 0. Now 15th one. Find the derivative of x cube log x plus 1 minus x by 1 plus x plus e power sin x with respect to x. So now let us take this x cube as u and log x as v, u, v. So derivating u dash, that means d by dx of u. So d by dx of u, that means d by dx of x power 3. Already I said the formula of d by dx of x power n equals to n into x power of n minus 1. That means 3 into x power of 3 minus 1. So that equals to 3x square. And v dash equals to log x. So d by dx of v is 1 by x. Now x cube into log x, that equals to u dash v, u into v. Formula is u dash v plus uv dash, that equals to u dash 3x square into v log x plus x cube into 1 by x. The value is 3x square log x plus x square. Next, this term is finished. Now 1 minus x by 1 plus x. Take this 1 minus x as u and 1 plus x as v. U dash that equals to u dash of 1 minus x, that equals to minus 1, and v dash equals to 1. U by v, formula is u dash v minus uv dash by v square. U by v formula is u dash v minus uv dash by v square. So now substituting this u dash, v dash and uv values in this formula, get the value of minus 2 by 1 plus x whole square. Now taking this value, e power sin x. So u equals to sin x, only u. Now u dash equals to d by dx of sin x is cos x. So d by dx of e power sin x is e power sin x into cos x. So that means the values are first one, x cube log x, 3x square log x plus x square minus 2 by 1 plus x square plus e power sin x cos x. This is the derivative. Next one. Find all first and second order partial derivatives of u equals to x cube minus 8xy plus y cube and verify that dou square u by dou x dou y equals to dou square u by dou y dou x. We know the first order partial derivative. Dou u by dou x, that equals to x cube minus 8xy plus y cube. So here only taking this x value, that means derivating the values which has x coefficients. So x cube, this is taken, and here y cube, we are not derivating y cube, so y cube in this value is 0. So x power 3, that means 3 into x power 3 minus 1, so 3x square minus 8 y, x is eliminated, and du by dou y, that means minus 8x plus 3y square, and dou square u by dou x square, here derivating this one. So dou square u by dou x square equals to 3 into 2, that means 3 into 2 6, 6 into x power 2 minus 1, so 6x. Dou square u by dou y square, this one derivating this one, minus 8x is 0, 3 into 6, 6y. So dou square u by dou x dou y, dou square u by dou x dou y is equals to minus 8. So that means then the value is dou square u by dou x dou y equals to dou square u by dou y dou x, hence proved. Next, part C, 16th one. One end of a ladder 17 feet long is leaning against a vertical wall. If the foot of the ladder is pulled away from the wall at the rate of 3 feet per minimum, how fast is the top of the ladder descending when the foot of the ladder is 8 feet from the wall? Now let's call the distance between the foot of the ladder and the wall. That means foot of the ladder to wall is x and the height of the ladder as y. And we can use by Pythagoras theorem. So taking it, relating the values, so drawing a diagram based on the given information. This is the height and this is the distance between the foot of the ladder and the wall, and this is the height of the ladder on the wall. So by applying Pythagoras theorem, they have given that x square plus y square equals to 17 square. Now differentiating both sides with respect to the time t. So 2x into dx by dt plus 2y into dy by dt, that equals to 0. Let us take this as equation 1. Now they have already given that the rate is 3 feet per minimum. So dx by dt is minus 3 feet per minimum. That means when x equals to 8 feet, we need to find the value y. So by explaining, that means by substituting the value of x equals to 8 feet here in the place of x, we get the value of y value 15 feet. So now substituting this y value in this equation 1, we get the value. So we got the x value and we got the y value. So substituting x value and y value in this equation 1, we get the value of dy by dt. So 2 into x, that means 8 into dx by dt. Dx by dt is already given that minus 3 plus 2 into 15 into dy by dt. So by solving this value, dy by dt equals to 8 by 5 feet per minimum. So when the foot of the ladder is 8 feet from the wall, the top of the ladder is descending at a rate of 8 by 5 feet per minimum.